Welcome to myprojectbuzzer.com. Here we discuss about the fault-based test minimization using genetic algorithm for two-stage combination circuit. In our project, present a new genetic algorithm to minimize a test pattern for benchmark circuit. Genetic algorithms have been very effective for benchmark circuit test generation, especially when combined with a deterministic algorithm. Time complexity is polynomial to generate the tests that predict all the structured faults in the circuit. This proposed genetic algorithm uses a Boolean function in sum of product form. The fault detection problem in benchmark circuit is formulated in a few frameworks. In this, the proposed system evaluatory principles are employed in test minimization stage alone. Test minimization stage is comparisons in deterministic and heuristic methods. The results show that the test sets generated using the evaluation approach are some compact than those generated by earlier approach for many circuits. In addition, a survey and evaluation techniques for optimizing the test set in digital circuits is performed. The surveyed methods are widely accepted by the industries manufacturing digital circuits. A very brief introduction to enter the flow of test minimization process is also presented. The most popular fault model used in practice is the single stacker fault model. In this model, one of the signal lines in a circuit is assumed to be stuck at a fixed logic value regardless of what inputs are supplied to the circuit. Hence, if a circuit has n signals lines, these are potentially 2n stackered fault defined on the circuit, of which some can be viewed as being equal to others. The stackered fault model is a logical fault model because no delay information associated with the fault definitions. It is also called a permanent fault model because the fault effect is assumed to be a deterministic algorithm is an algorithm which given a particular input which always produces the same output with the underlying machines always passing through the same sequence of states. Deterministic algorithms are by far the most studied and familiar kind of algorithm, as well as one of the most practical since they can be run on a real machines efficiently. In our proposed system, we propose a genetic algorithm to minimize test patterns for benchmark circuit. Exploration of a larger number of candidate solutions overrides the exploration of good solution. Because of the large number of invocation of the genetic algorithm and the high cost of accuracy fitness evaluation, the genetic algorithm parameter must be set to reduce the computation. Now we discuss about the system flow diagram. The system flow diagram represents the flow of our operations. The orange bits give the check data operation. The check data operation check the in our process fault or non-fault identification. Then finally we pass our output into the genetic algorithm. The genetic algorithm consists of 4 submutation, fitness, crossover, and selection based methods. These methods are completed after the output passes into the lookup table condition. If the condition matched, our output is non-fault. In case of not matched, this is a faulty output. And now we are going to discuss about running procedure of our project. In this process we have 4 steps. First step we check the syntax error, then second step we generate the actual schematic diagram, then third step we generate the technology schematic diagram, then finally we generate the simulation waveform. First we select the implementations. Now we are going to the first step. Please click check syntax and run the step. In this step, check the syntax error of our program. In case of any error and warnings, the display in our console black. Now in our project we have no error. Then now we are going to the second step. Please click view RTL schematic and run the procedure. Please add and create schematic. This is our overall RTL schematic diagram. A, B, C, E, clock, reset, spin. These all are our input signal. Our outputs are channel, stuck fault, stuck 1, W, Y, Z. These all are our output signals. This is our overall RTL schematic diagram. Now we are going to the third step. Please click View Technology Schematic Diagram and add and create schematic. This is our overall technology schematic diagram. This is our overview of technology schematic diagram. Now we are going to the final step of our project running procedure. Please select simulation, select simulate behavior model and run that. These 7 signals are our input signals. These 5 are our output pair. Now we give the input signal. Then we give the second input signal values. Now we give the spin value to 0, reset value set to 1, clock value set to 0. Please run. This is our reset condition output values. Now change the clock signal value set to 1, reset value set to 0, spin value set to 1. Then again change the clock values simultaneously, zeros and ones. Now change the spin value set to 0. Change the clock value to 1, 0. This is our overall outputs. Now we complete our running procedures. Thank you.